Finding a sustainable and clean power source for the planet has been a pressing issue for many years now. This issue has caught the attention of a vast array of interest groups, including national and local governments, industrial companies and small businesses, environmentalists and naturalists, scientists and university researchers, and most of all, power-producing companies. Each of these groups have attempted to find alternative sources of energy production besides that of coal and oil. Some of the most widely accepted alternatives to date have been solar and wind sources of power. More controversial alternatives have been natural gas, hydropower, and nuclear power because of their potential adverse side effects. Finding an alternative to the dominant source of power for the last 200 years has been a long and difficult process, but has proven necessary and timely. Coal and oil reserves will most likely run out in the next century at the current usage rates, and the prospect of global warming becoming irreversible gives this issue its exigence and necessity. Re-evaluating some of these alternatives and their viability has come to the forefront of the issue in recent years, specifically nuclear technology. The Sierra Club is an organization dedicated to protecting the environment and natural areas, and is therefore a stakeholder in this wide-ranging debate. The Sierra Club's members include environmentalists, naturalists, and outdoor enthusiasts. One of the Sierra Club's founding principles is to educate and inform the public about the environment, environmentalism, and the group's policies and ideology. One such policy has been to keep energy production clean and safe for the environment. On their website, a prominent banner is displayed that has the organization's 3 areas of focus: move beyond fossil fuels, preserve our wild America, and enjoy the outdoors. Under this banner, there are 3 graphics that further demonstrate the Sierra Club's dedication to moving beyond coal, oil, and natural gas. Nuclear-free future is then listed in the Sierra Club's specific programs. Under this webpage, there is a brief description of the Sierra Club's stance on nuclear energy, which can be summed up by the first sentence. The Sierra Club remains unequivocally opposed to nuclear energy. The Sierra Club's stance on nuclear energy is clear and grounded in historical evidence, with many of the points that they make about nuclear energy standing true today. These reasons include significant upfront costs to building and starting a new plant, that nuclear waste is extremely harmful to the environment, mining for nuclear fuel still uses fossil fuels, and that plants are inherently dangerous and capable of being turned into nuclear weapons. These concerns have all been proven to be legitimate and valid in the past years, with disasters at nuclear power plants such as Chernobyl and Fukushima, which involved nuclear meltdowns and deadly radiation. While these concerns continue to remain valid with the current state of the nuclear power industry, some re-emerging technology could soon counter the prevailing stereotypes of nuclear technology. Once again, implementing thorium into nuclear power cycles will demand that nuclear technology be reconsidered. The Sierra Club should consider that using thorium as a source of nuclear fuel can be an environmentally friendly alternative to past nuclear technology because of its higher sustainability, reduced environmental impact, and inherent safety. Traditional nuclear technology has not been seen as inherently sustainable up to this point, but using thorium as a nuclear fuel could change the narrative due to its availability and energy potency. Thorium is a naturally occurring metal that can be found in small amounts in most soils on Earth. In an article published in the academic journal Energy Conversion and Management, the authors describe how thorium is much more abundant than most nuclear fuels that are used today and is estimated to be 3 to 4 times more abundant than uranium in the continental crust. They also explain how thorium is most commonly found in monazite beach sands around the world, with the highest concentrations found in India. According to their research, extracting thorium from monazite beach sands can be more efficient than the traditional extraction of uranium ore through mining, and the processing of beach sands is already taking place to extract other valuable minerals. Because of thorium's availability, nuclear power could be feasibly implemented in all parts of the globe. Dr. Rusty Towell describes how thorium can be a sustainable source of power for hundreds of years because of its potency and availability while giving a TEDx talk earlier this year. Towell describes how in 1 cubic meter of soil there is on average 2 cubic centimeters of thorium. He then states that That small amount of thorium can produce enough energy to supply all the electricity I ever need in my life. Considering this prospect, both the authors and Towle contend that using thorium in a fully closed nuclear fuel cycle could help power the globe for centuries, which could be the new definition for sustainability. Using thorium in nuclear reactors has proven to be an efficient and low carbon emission energy source, according to the latest research. In the article, Techno-Economic Assessment of Thorium Power in Canada, published in the academic journal Annals of Nuclear Energy, the authors analyzed the efficiency and economic feasibility of a reactor that uses thorium compared with a conventional uranium reactor. In their analysis, they used data from nuclear reactors in Canada, the cost of the materials and electricity in Canada, and data analysis tools to analyze the results of using thorium in a reactor. The reactor analyzed in their paper is called the Canada Deuterium Uranium Reactor, or known as CANDU, which is a type of pressurized heavy water reactor that is currently used throughout Canada. Firstly, the authors conclude that the CANDU reactor could be a viable host for this alternative technology. The feasibility and cost of implementing thorium into the CANDU reactor is then discussed. Although they find that the cost of converting the thorium ore into usable fuel is more expensive than that of uranium, the overall cost for thorium is less per year than that of uranium because of its potency. The authors demonstrate how thorium is one of the highest melting temperatures of any metal, which is advantageous to the creation of usable energy. Finally, the authors take into account all of the costs of running a nuclear power plant to conclude that the cost analysis shows that a thorium plant is financially more attractive than a uranium plant due to the higher burnup of thorium fuel. They also offer evidence that currently uranium nuclear power plants are cleaner and cheaper than coal-fired and gas-fired plants, and that a thorium-powered plant will be even more efficient when used in Canada. Finding a more efficient and cleaner power source is a main goal of the Sierra Club, and thorium could be that source. Nuclear power plants fueled with thorium have been shown to be cleaner than fossil fuel powered plants, and they could also provide other benefits. One such benefit is that thorium could be used to reduce current nuclear waste. In an article published in the AIP conference proceedings, Dr. Sahin, a renowned professor of nuclear technology, discusses how thorium is a preferable source of nuclear fuel because its byproducts are more easily rid of their radioactivity than a uranium-fueled reactor. Sahin describes how the thorium cycle produces uranium-233, which is beneficial in two ways, one of which will be discussed later. One of the two benefits of uranium-233 is that it could easily be denatured by adding a few fractions of uranium-238 and natural uranium to thorium. Dr. Sahin describes that by adding the uranium-238, the byproducts of the nuclear cycle will become less radioactive by having a shorter half-life, which in turn means that there will be extremely low impact to humans or the environment. In Dr. Towle's talk, he describes some of the other benefits that will come with the acceptance and implementation of thorium nuclear power. Although the benefits he discussed can only be harnessed in a liquid fluorite thorium reactor, or LIFTR, which are still being researched and designed. This reactor uses molten fluorite salt that can absorb the energy of the nuclear reactions and transport it to a heat exchanger. In a secondary process, the excess heat produced by the reactions can be used to desalinate water. By implementing this secondary process, clean water can be provided to the many people around the world that do not have access to it. According to Towle, this reactor also has a unique ability to harness the waste products of a nuclear cycle and convert them into usable medical isotopes. These medical isotopes can be used to cure cancer. Using them as targeted alpha therapy yields a product called a smart bomb for cancer cells. These medical isotopes are 1,000 times more effective than in radiation treatments, according to medical doctors. Finally, Towle contends that using a LIFTR for 1 year would produce less than 1 quart of nuclear waste. While these benefits seem to be miraculous, and will require more research and testing, the technology for a molten salt reactor has been around since the 1960s, and the U.S. successfully tested one for 4 years. These benefits could reduce the impact that nuclear technology has on the environment by reducing the amount of waste from a nuclear reactor to negligible, producing much less greenhouse gas emissions than fossil fuels, and creating a cheap source of power. Nuclear waste has been a main concern for the Sierra Club, but thorium could eliminate that problem while also reducing emissions and bettering the lives of many around the world. While Towell discusses the immense benefits of a closed-cycle nuclear reactor, such as a lifter, Ashley and others give further evidence to why open-cycle nuclear reactors can still be an efficient and clean source of power. In their article, Life Cycle Impacts from Novel Thorium-Uranium-Fueled Nuclear Energy Systems, the authors analyze the impacts of using thorium in 3 different types of open-cycle reactors. One of the reactors analyzed is similar to the CANDU reactors that were studied in Canada by Graves and others. In the introduction of the article, the authors state 4 reasons why open-cycle reactors might be more feasible than a closed-cycle reactor. These reasons are that they have significantly lower fuel cycle costs, lower infrastructure requirements, greater resistance against nuclear weapons proliferation, and enhanced protection against diversion and theft. The authors detail the life cycle impact of the reactors and focus on the procurement of the nuclear fuel. According to their research, processing and separating requirements produce the greatest emissions. They then go on to state that overall, recovering thorium from monazitic beach sands had lower emissions than the traditional extraction of uranium. In their conclusion, they found that total emissions from an open-cycle, thorium-fueled nuclear plant would be similar or slightly higher than that of a uranium plant due to processing constraints, but that the range of carbon dioxide emissions from these 4 technologies appears to be low in comparison to the majority of electricity-generating technologies, and this prospect will add further robustness to the claim that nuclear energy can yield electricity with low carbon emissions. While it is obvious that nuclear power still produces greenhouse gases due to procurement of fuel, the overall production of CO2 per kilowatt hour is much lower than almost all other types of electricity production used today. The Sierra Club should consider that other green alternatives produce a similar amount of greenhouse gases while not being as efficient as a thorium nuclear plant could be. Finally, one of the most important reasons to consider using thorium as a nuclear fuel is its inherent safety. Returning to Dr. Sahin's work, his second benefit to using thorium as a fuel is that it contains uranium-232, which decays faster and leads to a high level of deterrence and would make handling and diversion difficult, even impossible for clandestine misuse by terrorist groups or states. This has been one of the main fears around the proliferation of nuclear technology. Secondly, as previously discussed by Towell and Sahin, waste from a thorium reactor can be dealt with much more quickly than that of a uranium reactor. Nuclear waste from a thorium reactor can be denatured easily, and in some reactors, such as the lifter, there would be little waste to begin with. Less waste and greater control means that there is far less impact on the environment, and more importantly, the humans involved. Further confirmation of thorium's safety is explained in an article published in Nuclear Engineering and Design by Aline and others. The article assesses the safety and accident risks of using thorium as a nuclear fuel. In their assessment, the authors use accident simulation tools to test the risk of there being an accident in the life cycle of a thorium reactor. They conclude that the results and others show that all safety requirements are fulfilled for the fuels they tested. Finally, in Towell's presentation, he discusses the design of the lifter and how it would be walk-away safe. In his description, there is a frozen fluorite crystal at the bottom of the reactor that would melt if the reactor exceeded the working temperature. Upon melting, the nuclear fuel left in the reactor would drain into a storage tank underground, or it would be safe from leakage and theft. This fail-safe design of a reactor and the decreased weaponization capacity are two factors that make thorium a nuclear fuel that should strongly be considered. Thorium is a material that is common in almost all types of soil. Harnessing the potential energy from thorium through nuclear fission could be a process that changes the way clean energy is defined. Using thorium has many benefits over current nuclear power and other electricity production. These benefits include lower greenhouse gas emissions, cheaper electricity, fuel availability for hundreds of years, increased safety over current nuclear technology, and even the prospects of creating clean drinking water and cancer-fighting medical isotopes. Nuclear power has the ability to impact the world in positive ways. It will allow for cleaner air for generations to come and healthier forests for people to enjoy. Using thorium will also lessen the threat of nuclear terrorism and disasters, and cheap electricity from nuclear power will decrease poverty around the world. Current perceptions of nuclear technology need to be reevaluated because of the vast benefits that thorium can yield. The Sierra Club should consider that nuclear technology can in fact be safe, sustainable, and environmentally friendly.